Hello, everyone. My name is Cara and I'm a fifth year IGP student in NAU's IGP program. I'm studying French, and my subject major is physics and astronomy. I spent my fourth year abroad in France, and the title of my research project is Chemically Driven Janus Electromagnets using physical chemistry to alternatively generate magnetic fields. I spent my year abroad in Bordeaux, where I attended the University of Bordeaux and completed my internship. I chose to go to Bordeaux because I wanted to challenge myself to be in a smaller city where there would be more opportunities for me to speak French. In addition, the professor who owned the lab that I was working in at the time for NAU had a friend who was a research professor in Bordeaux, so I wanted to take advantage of that connection. I'm so happy to look back on this time and report that I absolutely thrived in this environment and still think back to France as a home. I feel like I really grew so much as a person thanks to the perspectives I gained over there and how they positively affected how I live even now. I really enjoyed traveling when I had breaks from school and work. For example, I really enjoyed my time spent in a region of France called Dordogne. It is right to the left of Bordeaux and just covered in rolling hills and cliff sides that are dotted with castles that are hundreds of years old. And though I loved living in Bordeaux, I spent most of my time out in the countryside enjoying French cuisine and the way of life in the tiny towns out there. From February to August 2022, this year, I did an internship with a lab on campus called the Analytical Nanosystems, which is a subgroup of Bordeaux INP, the University of Bordeaux, and the Institute of Molecular Sciences. I absolutely lived for this job, and the fact that 80% of the people working there were international made the experience really fun and intercultural. The group is largely composed of chemists. However, I played the role of the physics point of view in an elaboration of a previous project that focused on the synergy of electronic redox currents and magnetic fields, which employs many principles of fundamental physics. Since its discovery, electromagnetism has given rise to countless valuable developments, and even its most fundamental principles continue to be applied to modern concepts. Coupling spontaneous redox reactions at each extremity of a solenoid mimics a standard power source and introduces an unconventional wireless approach to shuttling electrons from one side to the other. During my internship, I applied this concept to magnesium platinum hybrid microswimmers possessing helical geometry to develop an alternative to spontaneously inducing magnetism. To test this theory, these swimmers were placed in a uniform magnetic field that was periodically reversed. The redox current flowing through the loops of the swimmer generates its magnetic field. And similarly to a compass, it proceeds to self-orient in alignment with applied exterior magnetic fields. The experimentally measured torque on the swimmer is proportional to the experimentally obtained values of its redox current. And through varying the concentration of the solution, we were able to fine-tune its angular velocity. This is the very first demonstration of a swimmer capable of producing its own magnetic field without any kind of ferromagnetic materials. This shows that the use of ferromagnetic materials is not absolutely necessary anymore in the fabrication of magnetic micro devices and swimmers. And in fact, theoretically, any two redox pairs may be used in combination with solenoidal geometry in order to achieve this electromagnetic effect. In the future, I would love the opportunity to explore collective behavior of these little guys and even apply this theory to create biological electrochemical magnets using the traditional concepts behind enzymatic biofuel cells. This internship was absolutely unforgettable and really showed me the kind of environment and subjects suit me the best as far as future research goes. So yeah, thank you so much for listening, and yeah, that's it.